Hi, welcome back. This is Professor Ridge, and today's lesson is on 8.7, the binomial theorem. So we're going to look at the binomial expansions using Pascal's triangle. So we're going to consider the following expanded powers of a plus b to the n, where a plus b is any binomial and n is a whole number. So we do a plus b to the 0 is going to be equal to 1. A plus b to the first is a plus b. A plus b squared is a squared plus 2ab plus b squared. A plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. A plus b to the fourth is a to the fourth plus 4a cubed b squared, b, plus 6a squared b squared plus 4a b cubed plus b to the fourth, and then a plus b to the fifth is a to the fifth plus 5a to the fourth b plus 10 a to the third b squared plus 10 a squared b third plus 5 a b to the fourth plus b to the fifth. Okay, so now if we look at what's known as Pascal's triangle, you start with 1, and you do 1, 1, and then you, so basically you're going down the side of that is 1, and you take this 1 plus 1 is 2, and then you go down the side 1, 1 plus 2 is 3, 2 plus 1 is 3, 1. So this is n equals 0, n equals 1, n equals 2, n equals 3, n equals 4. So if I go to the fourth level, I'm going to get 1, 4, 6, 4, 1. N equals 5, you get 1, 5, 10, 10, 5, 1. N equals 6, you're going to get 1, 6, 15, 20, 15, 6, 1. And then let's do one more. N equals 7. You're going to get 1, 7, 21, 35. We get 35, 21, 7, 1. Okay, so that's so on. You can keep going. So that's Pascal's triangle. And if you go back and look at our expansions here, you'll see the 1, 1, 2, 1 for the third row. The fourth row, well, the third row meaning n is 2. Then if we go to the cube, it's cube. So if you look at this fourth row, which is cubed, you got 1, 3, 3, 1. So basically, those are the coefficients in the binomial expansion. So these, in Pascal's triangle, they're what we call the binomial coefficients. Okay, so the binomial theorem using Pascal's triangle says that for any binomial a plus b and any natural number n, a plus b raised to the nth power is c sub 0 a to the n times b to the 0 plus c sub 1 a to the n minus 1, b to the 1, plus c sub 2 a to the n minus 2 b squared, plus dot dot dot, plus c sub n minus 1 a to the first, b to the n minus 1, plus c sub n a to the 0, b to the n, where the numbers c0, c sub 1, c sub 2, so on to c sub n are from the n plus 1 row of the Pascals triangle. So let me just show you a quick example. If I ask you to expand say x plus 2 to the third power. We'll just do something real easy here. So the idea is we're going to do, we're going to look at that third row of, well, the fourth row. So 3 plus 1 row is 1, 3, 3, 1. Hopefully I left enough space. And then notice that the powers are going to be the first term cubed, second term 0. First term squared, second term to the first. First term to the first, second term squared, first term to the 0, second term cubed. So we're going to get 1x cubed plus 3x squared times 2 plus 3x times 4 plus 1 times 1 times 8. So we're going to end up with x cubed. So I'm going to end up with x cubed plus 6x squared plus 12x plus 8. That's my final answer. So that's using the binomial theorem. Let's try another one. Let's expand 2x plus y to the fourth. So the 2x is my a. And again, I'm going to go 4 plus 1, which is the fifth row. Which, if I look at my fifth row, I get fifth row 1, 4, 6, 4, 1. I'm going to put a lot of space. 1, 4, 6, 4, 1. Those are my binomial coefficients. And I'm going to go 2x, y, 2x, y. And notice I haven't done any powers yet because I'm going to show you the pattern. It's real easy. My favorite word, right? Real easy. 2x, y. And so basically we're going to start with n, which is 4, and then 0. And they always have to add up 4. And then the first term, the a, is going to go down, so it's going to go 4, 3, 2, 1, 0. And the b term, in this case it's y, it's going to go up, 0, 1, 2, 3, 4. So 4, 3, 2, 1, 0. Then this one is going to go 0, 1, 2, 3, 4. And we get, now we've got to simplify all that. So we're going to get 16x to the fourth y plus 4 times 8x cubed y plus 6 times 4x squared y squared plus 4 times 2x times y. I'm just going to write 8x y cubed plus y to the fourth. So I'm going to get 16x fourth y plus 32x cubed y. And normally I would skip that step and just write this final one. I just want you to see where it's all coming from. 24x squared y squared plus 8xy cubed plus y to the fourth. Okay, so that's expanding using Pascal's triangle. Now it turns out that Pascal's triangle, you can get the coefficients using the n choose r notation. Those are the binomial coefficients. So we can get, for Pascal's triangle, we get 0 choose 0, that's 1. 1 choose 0 is 1. 1 choose 1 is 1. 2 choose 0 is 1. 2 choose 1 would be 2. 2 choose 2. And then 3 choose 0. 3 choose 1. 3 choose 2. 3 choose 3. This is number 4 choose 0. 4 choose 1. 4 choose 2. 4 choose 3. And 4 choose 4. So just to show you, like 4 choose 2 is 4 factorial over 2 factorial, 2 factorial, which is 4 times 3 over 2 times 1, which is 6. See? 6. Okay, so we can use the binomial coefficients using that notation, the n choose r notation. Well, that's called binomial coefficient. Okay, so we can rewrite the binomial theorem using this factorial notation. So a plus b to the n equals n choose 0, a to the n, b to the 0, plus n choose 1, a to the n minus 1, b to the 1, plus so on until you get to n choose n, a to the 0, b to the n. So it's the same thought process. So instead of looking at Pascal's triangle, you can figure, especially if you have that button on your calculator. So let's try 1. Okay, so let's try 3x plus 2y squared to the fourth. So I'm going to go 4 choose 0, the first term, to the fourth, the second term, 0. 4 choose 1, first term, to the third, second term, to the first. 4 choose 2, first term, squared, second term, squared, plus 4 choose 3, first term. So remember, we're going down for the first term. So it's 4, 3, 2, we're down to 1. Second term's going up, so it's 0, 1, 2, now we're on 3. 2y squared cubed. And then 4 choose 4, the first term to the 0, the second term to the fourth. And then you just got to simplify each of these. So 4 choose 0 is 1. 3x to the fourth is 81x to the fourth times 2y squared to 0 is 1. 4 choose 1 is 4. 3x to the third, 3x is in parentheses, so that's 27x to the third times 2y squared. 4 choose 2 is 4 times 3 is 6. And then we get 3x squared, that would be 9x squared, 3x in parentheses squared. So that's 9x squared. And then we get 2y squared, 2y in parentheses, 2y squared in parentheses, and then we square that, that's 4y to the fourth, plus 4 times 3x times 8y to the 6, plus 4 choose 4 is 1, 3x to the 0 is 1, 16y to the 8th. And then you just got to clean everything up. So we're going to get 81x to the 4th plus, I should have done one of these with a minus in there. Oh well. Hopefully you figure it out. 4 times 27 times 2 is 216. X cubed y squared. 6 times 9 times 4 is 216 again. X squared y to the 4th. And then 4 times 3 times 8 . 96. xy to the 6. And then the last term is just 16y to the 8th. And now we're done. Okay, let's try this one. It says find the 5th term in the expansion of 2x minus 5y to the 6th power. So now the first thing is, remember, right, we're going to have 6 choose 0, 6, 0. So that's going to be the first term. So remember, if I want the 5th term, this number on the bottom is going to be 1 less. So the 5th term is going to be 6 choose 4. And then we're going to do the first term, 2x, and the second term is negative 5y. And the thing to note is the bottom number, the 6 choose 4, that goes for the second term. If you go back and look at the pattern, that's 4. And then remember, the 4, both of the powers have to add up to the 6. So this would be 2x squared. So the 5th term is going to be equal to 6 choose 4, 2x squared, negative 5y to the 4th. So we're going to do 6 choose 4. Which is 15. 2 squared, 2x times 2x is 4x squared. Negative 5 to the 4th power is 625 positive. Y to the 4th. So we're going to multiply all that together. 60 times 625. So 15 times 4 is 60 times 625. 37500. X squared y to the 4th. So that's the 5th term. Okay, so here's the formula I just used. I showed you how to reason through it, but basically that's the idea. So the k plus first term of a plus b to the n is n choose k, a to the n minus k, b to the k. So just note that k. So remember, k is 1 less than the term you're going for. So if you want the 5th term, k is 4. Okay, and then the last thing in this section is total number of subsets. The total number of subsets of the set with n elements is just 2 to the n. And they give a nice little proof of that. So if you had a set with n elements, the total number of subsets is you have to do n choose 0 plus n choose 1. So this is the first one. number of subsets with 0 elements, which is just 1. N choose 1, N choose 2, dot, 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 all the way to N choose N. That'll give you the total number of subsets, which is going to be equal to, now if you consider the expansion, okay, so now consider the expansion of 1 plus 1 to the n. So you get 1 plus 1 to the n equals n choose 0 times 1 to the n, 1 to the 0. N choose 1, 1 to the n minus 1, 1 to the 1, plus dot, 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 n choose n, which is 1 to the 0, 1 to the n, which is, now 1 to any power is just 1, so basically that equals n choose 0 plus n choose 1 plus n choose 2 plus dot, 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 plus n choose n, which is precisely the total number of subsets with n elements. And notice that the left-hand side is 1 plus 1 n, and then just doing order operations, 1 plus 1 is 2 to the n. So that proves that the total number of subsets of a set with n elements is just 2 to the n. So it's a nice little proof, pretty elegant. Alright, so let's do an example. So basically we just use the shortcut now that we have that. Okay, so the set A, B, C, D, E has how many subsets? Well, from what we just proved up here, there's 5 elements in that set, so it's going to be 2 to the n, and we know n is 5 in this case, so 2 to the 5th equals 32. So it has 32 subsets. That's the total number. Alright, so that it'd be like you do all the subsets with 0, which is the empty set, all the subsets with 1, so there's 5 of those. There's A, there's B, there's C, there's D, E. Okay, and then all the subsets with 2, and so the total number would be 32 subsets. Okay, that concludes the lesson for 8.7. Go to my math lab, complete the exercise there, and I'll see you next time.